All right, so let's go ahead and jump into these notes. If you open that top flap, you will see the steps for how we solve and graph these absolute value inequalities. So filling in the blank, the first thing you're going to do is just like if you were to solve an absolute value equation, and you need to isolate the absolute value expression. So again, same thing that we did with the equations. If there's a constant over there or a coefficient of the absolute value, you're going to want to go ahead and undo those so that you just have the absolute value set equal to a certain number. Then, just like with the equations as well, you're going to rewrite the expression inside the absolute value bars as two separate inequalities. You're going to have both the positive and the negative case. The biggest thing that we forget here is this first bullet point right here, because you have to switch the inequality symbol when you are writing the negative case. So when you break it into your two inequalities, the negative case has to also switch the inequality symbol to keep it true, okay? And so because of this, I like to write the negative case first. This also ensures that when it graphs, like, it will already be in order from least to greatest of how it needs to graph. So if you write the negative case first, it just makes then when you go to graph your final answer a little easier. After you split it into those two cases, then this is the easy part. You're just going to solve both of those inequalities. And then after you solve, you're just writing your final answer. If it's an or, you'll write it with an or in between. Or if it's and, you'll write it in that condensed form where that x is in between that minimum and maximum value. Okay? So understanding that we're writing it in this form, what this means is that these absolute value inequalities really are just compound inequalities. So we're going to start with the greater than, because if this says the absolute value of x has to be greater than 2, remember absolute value is just distance from 0. So that means it has to be 2 or more in this direction, but that also means that it can be 2 or more to the left of 0 away. So when you have a greater than inequality, it is going to graph like an or compound inequality, because it has to be greater than 2 away from the middle, but there's two sides of our number line. So it can be more than 2 away on the left or more than 2 away on the right. So again, when you have this greater than sign, this is like great or. It's going to be an or inequality. If it's a greater than sign, great or. Okay? It should graph like an or compound inequality. I know that's not how you actually spell greater, but it's because I'm just trying to help you remember if it's a greater than, it's an or inequality. Okay? All right. So now we got 2 here. We're going to practice solving and graphing. We have 3 times the absolute value of x minus 2 is greater than 3. So just like with an equation, we want these absolute value bars, this part of the expression, to be by itself. So we're going to undo this multiplying by 3, and we undo that by dividing by 3. So that we are left with the absolute value of x minus 2 is greater than 1. Because 3 divided by 3 is 1. Now that this is isolated, we're going to break it into the two cases. And one case is going to be equal to the positive 1, and the other case is going to be equal to a negative 1, but not equal. What you have to remember is that you have to flip the sign when you do the negative case. So I'm going to rewrite this x minus 2 is less than negative 1, or x minus 2 is greater than 1. You don't have to write the negative case first. Again, I just like to do it because now when I have my final answer in the graph, it just makes more sense. because I have my lower value first. Now is the easy part. So now we're just solving for x. So all we have to do is add 2. So that we have x is going to be less than 1. Or if I add 2 over on this side, I get that x is going to be greater than 3. So then this is your final answer. X is less than 1 or x is greater than 3. And now that we have that final answer, we can graph it. Both of them are going to be open circles. So I have an open circle on 1, and I would shade to the left. And then I have an open circle on 3, and I shade to the right. So an absolute value inequality is really just a compound inequality. So really just a compound inequality. And as long as we remember this rule that when we do the negative case, we also have to flip the sign, you'll be good to go. All right, let's try one more all together. We have the absolute value of x plus 2 minus 6 is greater than or equal to negative 4. So again, step number 1, get this absolute value part by itself. So we're going to undo this minus 6 by adding 6. So that I get the absolute value of x plus 2 is greater than or equal to, well, negative 4 plus 6 is 2. Bless you. And now it's isolated, so we're ready to break it into its 2 cases. I'm going to write the negative case first, and I'm going to remember that when I write the negative case, I have to flip the inequality sign. So I have x plus 2 is less than or equal to negative 2. Or x plus 2 is going to be greater than or equal to 2. Now that I have the 2 cases, I just solved, so I'm just going to subtract the 2. So this is x is going to be less than or equal to negative 4, because negative 2 minus 2 is negative 4. Or when I subtract the 2 from the positive case, I get x is going to be greater than or equal to 0. So there is your solution. When I go to graph this on negative 4, I will have that closed circle, and I'll be shading to the left. And then on 0, I have a closed circle, and I'd be shading to the right. A greater than sign is like an or compound inequality, and it should graph apart. Cool? All right. Now let's flip over and look at the less than. So number 3, nope, let's go up here. If you have the absolute value of x has to be less than 2, that means the distance from the center has to be 2 or less away. But once again, we have 2 units on both sides of 0. So if I have this less than sign, it's going to graph like an and compound inequality, because it can be less than 2 or greater than negative 2. Graphing together, again, making it like an and compound inequality. So when you have a less than sign, less than just be less than. So if it's a less than, it's going to be like an and compound inequality. All right, which is going to allow us when we go to write our 2 cases to write it in that condensed form and to solve a little quicker than we can with an or. Because with the or, we got to break it into 2 cases. With this less than that we're about to look at, we can kind of graph it like we did, or solve it like we did the warm-up today. So first things first, we got to isolate that absolute value of x plus 3. So since we have this constant of the 6, we're going to go ahead and subtract the 6. So that I'm left with the absolute value of x plus 3 is going to be less than 8 minus 6 is 2. Now you don't have to write this because, again, I'm going to encourage you to use the condensed form. But you could break this into the 2 and do x plus 3 is greater than negative 2 and x plus 3 is less than 2. Because remember that first case, you have to switch the sign when you make it negative. Or, because this is an and inequality, we put that x plus 3 in the middle is less than 2. And then over here, we put that opposite, negative 2. And we've still flopped this sign. You do like the condensed form or you don't like the condensed form? All right, well then split it into the 2. And you're going to end up having the same answer. Do you want me to do it as split into 2? No? Yes? So I would do the x plus 3 is greater than negative 2 because I have to flip the sign. And x plus 3 is less than the 2. So minus 3 minus 3. I get x is going to be greater than negative 5. Then when I minus 3 from the positive case over here, I get that x is going to be less than negative 1. But when you go to write this solution, again, because it's an and, we're not going to write and in between. We're going to turn this around because if x is greater than negative 5 is my minimum, which is actually going to be less than x, but then x is less than negative 1. So then there's my final answer. Because x is between negative 5 and negative 1. Both open circles. If you write it in the condensed form before you solve it, you avoid having to figure out, okay, now how do I write this final answer in the condensed form? So I'll do the other one in the condensed form so you guys have one of each. Yes?
So like if we're taking a test and we like solve this, do we have to write it in the condensed form?
Well, luckily for you, if you're taking a test, it's going to be multiple choice. So you'll just have to know which one is the correct condensed form. Cool? But like on the formative tomorrow, if you have to write it, those are things I would be checking for, that's correct. Okay? All right, last one, number 4. And again, this one I'm going to solve it in the condensed form from the very beginning. That way you'll have one of each, so you can use whichever method you prefer. I've got to get the absolute value by itself first, so I'm going to subtract the 9, which leaves me with 5 times the absolute value of x minus 1 is less than or equal to 20. Then I divide by the 5, giving me the absolute value of x minus 1 has to be less than or equal to 4. So that less than or equal to 4 means 4 units away from both sides of 0. So 4 units away from both sides is the negative 4 and the positive 4. So I can take this expression, I'm going to move it over here because I'm going to run out of space. And I'm going to put it in the middle. X minus 1 is less than or equal to 4, but it's greater than or equal to the negative 4. So now I've written it like that and compound inequality from the beginning. And I can solve it like we did with our warm-up today, where all we have to do is just add 1 to both endpoints. And this becomes negative 3 is less than or equal to x, which is less than or equal to 5. So then now that it's in that condensed form, that solution is correct. So I've got a closed circle on negative 3, a closed circle on 5, and I'm shading in the middle. All right. So like I said, of the